A free and open-source graphics device driver is software that controls computer graphics hardware and supports graphics rendering APIs and is released under a free and open-source software license. Graphics device drivers are written for specific hardware to work within the context of a specific operating system kernel and to support a range of APIs used by applications to access the graphics hardware. They may also control output to the display, if the display driver is part of the graphics hardware. Most free and open-source graphics device drivers are developed via the Mesa project. All hardware developers provide device drivers for their products over a range of operating systems. But some developers of graphics hardware provide no free and open-source drivers for their hardware, and they provide little or no technical documentation to support independent development of free and open-source device drivers for their products. The free and open-source device drivers available for hardware with support for independent driver development are generally of much higher quality in terms of completeness, stability, security and performance than drivers for hardware that lack such support. Drivers without freely available source code are commonly referred to as binary drivers. Binary drivers used in the context of operating systems that are prone to ongoing development and change, such as Linux, create problems to both end users and package maintainers. These problems affect system stability, overall system security, and performance, and are the main reason for the independent development of free and open-source drivers. When no technical documentation is available, an understanding of the underlying hardware is often gained by clean-room reverse engineering. Based on this understanding, device drivers may be written and legally published under any chosen software license. There are rare and special cases, where manufacturers' driver source code is publicly available in the Internet, but not under a free license. This means that the code can be studied and altered for personal use, but the altered source code cannot be freely distributed, so solutions to bugs in the driver cannot be shared, significantly reducing the utility of such drivers in comparison to completely free and open-source drivers. Problems with binary drivers. From a software developer's perspective. There are a number of objections to binary-only drivers. There are philosophical and ethical objections, with some feeling that drivers distributed without source code are against the beliefs of the free software movement. There are very pragmatic objections regarding copyright, security, reliability and development concerns. As part of a wider campaign against binary blobs, OpenBSD lead developer Theodor Raupt has pointed out that with a binary driver there is no way to fix it when it breaks, and that once a product which relies on binary drivers is declared to be end-of-life by the manufacturer, it is effectively broken forever. The project has also asserted that binary drivers hide bugs and workarounds for bugs, a comment that has been somewhat vindicated by flaws found in binary drivers, including in October 2006 an exploitable bug in NVIDIA's 3D drivers discovered by Rapid7. It is speculated that this bug has existed since 2004, although NVIDIA have denied this, asserting that the issue was only communicated to them in July 2006 and that the 2004 bug was a bug in Xorg, not in NVIDIA's driver. Another problem with binary drivers is that they often do not work with current versions of open-source software, and almost never support development snapshots of open-source software. For example, it is usually not directly possible for a developer to use NVIDIA's or ATI's proprietary drivers with a development snapshot of an X server or a development snapshot of the Linux kernel. Furthermore, features like kernel mode setting cannot be added to binary drivers by anyone but the vendors, which prevents their inclusion if the vendor lacks capacity or interest. In the Linux kernel development community, Linus Torvalds has made strong statements on the issue of binary-only modules, asserting, "I refuse to even consider tying my hands over some binary-only module," and continuing, "I want people to know that when they use binary-only modules, it's their problem." Another kernel developer, Greg Krach-Hartman, has commented that a binary-only kernel module does not comply with the kernel's license C the GNU General Public License C it just violates the GPL due to fun things like derivative works and linking and other stuff. Writer and computer scientist Peter Gutmann has expressed concerns that the digital rights management scheme in Microsoft's Windows Vista operating system may limit the availability of the documentation required to write open drivers, as it requires that the operational details of the device be kept confidential. In the case of binary drivers, there are also objections due to free software philosophy, software quality and security concerns. There are also concerns that the redistribution of closed-source Linux kernel modules may be illegal. By choice, the Linux kernel has never maintained a stable in-kernel application binary interface. There are also some concerns that proprietary drivers may even contain backdoors, like one that was found in Samsung Galaxy series modem drivers. From a hardware developer's perspective equals application-specific integrated circuitry, and microprocessors, when designed with the primary goal of efficiency, with regards to power consumption, silicon usage, and the actual acceleration of the calculations required to rasterize 3D wireframe models, are actually pretty simple and straightforward. When applications, such as a 3D game engine or a 3D computer graphics software, shunt calculations from the CPU to the GPU, they usually use a special-purpose API, like OpenGL or Direct3D, and do not address the hardware directly. Because all translation from API calls to actual GPU opcodes is done by the device driver, it will contain a considerable amount of specialized knowledge and be the constant object of optimization. This takes time and involves significant financial investment. Thus, leakage of device driver source code, whether published under a free license or not, can give competitors an advantage, especially newcomers to the business of graphic acceleration, who would gain a considerable amount of know-how without bearing the costs of developing that knowledge. The desktop computer market was for a long time dominated by PC hardware using the x86/x86-64 instruction set, and by GPUs available for the PC. With only three major competitors, NVIDIA, AMD and Intel, the main competing factor was the price of hardware and raw performance in 3D computer games. The display driver is an inherent part of the graphics card, as is the video decoder, hardware designed to assist in the calculations necessary for the decoding of video streams. As the market for PC hardware has been dwindling, it seems highly unlikely that new competitors will enter this market. Thus, it is unclear how much more know-how one company could gain by seeing the source code of the drivers of the other companies. Intel maintain only free and open source driver for Linux. The mobile sector, however, presents a different situation. The functional blocks are separate SIP blocks, since the hardware devices are very different from each other. Some portable media player do require a display driver and gains from video decoding acceleration, but do not require any sort of 3D acceleration, etc. The development goal is not only raw 3D performance, but also system integration, power consumption and 2D capabilities. There is also an approach to abandon the traditional method of updating the display and make better use of the possibilities that came with the sample and hold technology to significantly lower power consumption. There are more competitors on the market and there are newcomers. Usually CPU and the GPU are integrated on one die and also share the main memory, which is considerably slower than the distinct graphics memory and graphics cards for desktop PCs. Yet, this is cheaper, smaller and does benefit power consumption because there are fewer components needed. The growing mobile market, the unsatisfied requirements of mobile devices and the advantages that can be gained by the development of new techniques leaves much more room for the existing competition and for new competitors entering the market. Thus the SIP and the software supporting it can be considered more prone to discretion and a quick launch to market. When looking at the fact that during the second quarter of 2013, 79.3% of smartphones sold worldwide were running some version of Android, it is clear that the Linux kernel is dominant on smartphones. Thus hardware developers have a huge incentive to deliver excellent Linux drivers for their hardware, but due to the competition, no incentive whatsoever to make these driver free and open source. Projects like Libibri try to combine the power of the existent Linux Android drivers with different platforms than Android. Additionally, there are ongoing efforts to write free and open source drivers by independent developers. Performance comparison. A source for real-world testing is Phoronix. They routinely run benchmarks comparing involving the free driver as well. For example, from March 19, 2011 http www.phoronix.com/ scan.php page =news_item &px =otizmg, from March 31, 2013 http www.phoronix.com/ scan.php page =article &item =nouveau_2639_ flip &num =1, a comparison from April 29, 2013 between FOSS and proprietary drivers, Phoronix, a comparison from October 27, 2013 between proprietary drivers on Windows 8.1 and Linux, Ubuntu Linux gaming performance mostly on par with Windows 8.1, a comparison from January 25, 2014 between FOSS drivers on Linux only, http www.phoronix.com/ scan.php page =article and item =Linux 2014 &num =1, a comparison from January 27, 2014 between proprietary drivers on Linux only, http www.phoronix.com/ scan.php page =article &item =linux_gpus_2014 start &num =1, a comparison from March 19, 2014 between Ubuntu with a free and open source graphics device driver distributed as part of Mesa 3D clearly outperforms Mac OS X 10.9.2 when playing OpenGL based on Otic on a MacBook Air 2013. It is uncommon for computer game magazines to report any benchmark testing on Linux. Benchmarks on Phoronix are limited in scope, primarily test games using Quake engine derivatives. Software architecture. The free and open source drivers are primarily developed on Linux and for Linux. They have been under constant development by the Linux kernel developers, by third-party programming enthusiasts and also by employees of companies such as e.g. AMD. Each driver is composed out of 5 parts: Linux kernel component DRM, Linux kernel component KMS driver, basically the device driver for the display controller, user space component libDRM, a wrapper library for the system calls of the DRM, should only be used by Mesa 3D, user space component in Mesa 3D. This component is highly hardware-specific, is being executed on the CPU and does the translation of, for example, OpenGL commands into machine code for the GPU. Because of the split nature of the device driver, marshalling is possible. Mesa 3D is the only available free and open-source implementation of OpenGL, OpenGL-ES, OpenVG, GLX, EGL and OpenCL. As of July 2014, most of these components are written conforming to the Gallium 3D specifications. There is a fully functional state tracker for Direct3D version 9 written in C and an unmaintained one for Direct3D versions 10 and 11 written in C++. Annotation: Wine contains an implementation of the Direct3D version 9. Another Wine component used to translate Direct3D calls into OpenGL calls, and it works on top of the OpenGL implementation in Mesa 3D. When the Gallium 3D state tracker for D3D9 is available, a patched version of Wine could be used, adapting it to use the D3D9 state tracker, and thus avoiding this conversion step. Note that these patches weren't accepted by mainstream Wine as of April 2014. The Gallium 3D state tracker for D3D9 device drivers have a direct interface to the Direct3D9 API, increasing the performance by a factor of 2 and more. All drivers in Mesa 3D as of July 2014 limited to OpenGL version 3.3. For other APIs, see the Mesa 3D article. Device-dependent X, an additional special and distinct 2D graphics device driver extra for Xorg server. The DRM is kernel-specific and has to be ported to FreeBSD, OpenBSD, and some other kernels. In general, there's a Visa driver for any operating system available. the Visa driver supports most graphics cards without acceleration and with display resolutions limited to a set of resolutions programmed in the video BIOS by the manufacturer. See for example FB. History The Linux graphics stack have been prone to a long evolution over the years, with some unnecessary detours due to the X-Window system call protocol. Understanding this history should help comprehend the current design and its late arrival. Free and open source drivers. In general, the VESA driver supports most graphics cards without acceleration and with display resolutions limited to a set of resolutions programmed in the video BIOS by the manufacturer. Also see, kernel documentation FB or the Phoronix test suite. ATI AMD AMD's proprietary driver AMD Catalyst for their Radeon is only available for Microsoft Windows and Linux. A current version can be downloaded from the Internet and some Linux distributions contain it in their repositories. The FOSS drivers for ATI AMD GPUs are all being developed under the name Radeon. The drivers still have to load proprietary microcode into the GPU to enable hardware acceleration. Radeon 3D code is split into 5 parts, the Radeon, R200 and R300 classic style drivers and R300G, R600G, Radeon C Gallium 3D style drivers. The Radeon supports the R100 series, the R200 supports R200 series, the R300G supports pre-unified shader model microarchitectures, R300, R400, and R500. The R600G supports Altiera scale-based GPUs. R600, R700, HD 5000 and HD 6000, the Radeon C supports all graphics core Next-based GPUs, HD 7000, HD 8000 and RX 200. An up-to-date feature matrix is available at Radeon Feature Matrix. There is for example support for video coding engine and unified video decoder. The free and open source Radeon graphics device drivers are not reverse engineered, but based on documentation released by AMD without the requirement to sign any non-disclosure agreement. Documentation has been released gradually beginning in 2007. This is in strong contrast to AMD's main competitor in the graphics field NVidia, which does offer its own proprietary drivers similar to AMD Catalyst, but does not provide any support or assistance to any free graphics initiatives. Beside providing the necessary documentation, AMD employees also actively contribute code to support their hardware and features of it. At GDC 2014, AMD announced they were exploring a strategy change to rebase the user space part of Catalyst on a free and open-source DRM kernel module instead of their proprietary kernel blob. All parts and components of the free and open-source Radeon graphics device driver are prone to a constant development by the core contributors and interested people worldwide. The performance optimizations were successful already in 2011, when the R300G was able to outperform Catalyst in some select cases. Current benchmarks can be found in this article in the performance comparison section. NVidia NVIDIA's proprietary driver NVIDIA GeForce driver for their GeForce is available for Windows XP x86/x86-64 and later, Linux x86 ARM-v7 OS X10.5 and later, Solaris x86/x86-64 and FreeBSD x86/x86-64. A current version can be downloaded from the Internet and some Linux distributions contain it in their repositories. NVIDIA GeForce Driver 331.13 beta from October 4, 2013 supports the EGL interface enabling support for Wayland in conjunction with this driver. NVIDIA's free and open source driver is called NV. This driver is very limited and supports only 2D acceleration, and Matthew Garrett, Dirk Hohndel and others claim its source code is obfuscated. In March 2010 NVIDIA has decided to deprecate NV and not add support for Fermi or later GPU, nor add support for DisplayPort to this driver. In December 2009 NVIDIA publicly announced they would not provide any support or assistance to any free graphics initiatives. On September 23, 2013, NVidia publicly announced that they would release some documentation about their GPUs. Nouveau is based almost entirely on information gained through reverse engineering. This project aims to produce 3D acceleration for Xorg Wayland utilizing Gallium 3D. On March 26, 2012, the DRM component of Nouveau was marked as stable and promoted from the staging area of the Linux kernel. Nouveau supports Tesla and earlier, Fermi, Kepler, and Maxwell-based GPUs. As of January 31, 2014, NVIDIA employee Alexander Corbeau committed an extensive patch set which adds initial support for the GK28 to Nouveau. In June 2014, CodeThink reported to run Wayland-based Western Compositor with Linux kernel 3.15, making use of EGL and a 100% open-source graphics driver stack on a Tegra K1. An up-to-date feature matrix is available at Nouveau Driver Feature Matrix. Current benchmarks can be found in this article in the Performance Comparison section. As of July 2014, Nouveau has not been able to outperform NVIDIA GeForce driver due to missing reclocking support. Tegra Re is the name of the project that is working in reverse engineering NVIDIA's VLIW-based Tegra series of GPUs that predate Tegra K1. NVIDIA distributes proprietary device drivers for Tegra through OEMs and is part of its Linux for Tegra development kit. As of April 2012, due to different business needs from that of their GeForce line of graphics cards, NVIDIA and one of their embedded partners, Avionic Design GmbH from Germany, are also working on submitting free and open-source drivers for Tegra upstream to the mainline Linux kernel. NVIDIA co-founder and CEO laid out the Tegra processor roadmap using Ubuntu Unity and GPU Technology Conference 2013. Intel Intel has a long history of producing or commissioning open-source drivers for its graphics chips, with the exception of their PowerVR-based chips. The 2D Xorg driver is called XF86 Video Intel. The kernel MODI setting driver in the Linux kernel does not use the video BIOS for switching video modes. As some BIOS include only a limited range of modes, this provides more reliable access to those supported by Intel video cards. Unlike the Radeon and Nouveau drivers, Intel does not intend to utilize the Gallium 3D framework for its graphics drivers. Intel has also recently put work into optimizing their free Linux drivers to have closer performance to their Windows counterparts, especially on Sandy Bridge and newer hardware where various performance optimizations have now allowed the free Intel driver to be able to outperform their proprietary Windows drivers at certain tasks. Some of these performance enhancements can also benefit users of older hardware. Support for Intel's LLC was added in Linux kernel 3.12. Intel has 20 to 30 full-time Linux graphics developers. Matrox Matrox develops and manufactures these products: Matrox Mystique, Matrox Pahia, Matrox G200, Matrox G400, Matrox G500. Matrox provides free and open-source drivers for all their chipsets older than the G550. Chipsets newer than the G550 are only supported by a closed-source driver. S3 Graphics S3 Graphics develops these products: S3 Trio, S3 VRGE, S3 Savage, S3 Chrome supported by OpenChrome. ARM ARM Holdings is a fabless semiconductor company which licenses SiP cores. They are known for licensing the ARM instruction set and CPUs based upon it, but they also develop and license the Mali series of GPUs. On January 21, 2012, Phoronix reported that Luc Verheyen was driving a reverse engineering attempt aimed at the ARM Holdings Mali series of GPUs, specifically the Mali 200 and Mali 400 versions. The reverse engineering project was presented at FOSDEM, February 4, 2012. On February 2, 2013, Verheyen demonstrated Quake 3 Arena in time demo mode, running on top of the Lima driver. Imagination Technologies Imagination Technologies is a fabless semiconductor company which licenses SiP cores. They are known for the licensing the MIPS instruction set and CPUs based upon it, but probably even more for developing and licensing the PowerVia series of GPUs. Intel has manufactured a number of PowerVia-based GPUs. PowerVia GPUs are widely used in mobile SoCs. Imagination Technologies do not provide a FOSS driver nor any documentation for their products. Due to its vast appearance in embedded devices, the Free Software Foundation has put reverse engineering of the PowerVia driver on a high-priority project list. PowerVia Reverse Engineering Project Vivante Vivante is a fabless semiconductor company which licenses SiP cores. They develop the GCXXXX series of GPUs. There is a proprietary and closed-source Linux driver from Vivante consisting of a kernel space and a user space part. The kernel component is available as open source, however the user space components, which consist of the GLES2 implementations and a HAL library, are not. These, however, contain the bulk of the driver logic. Vladimir J. van der Laan found out and documented the state bits, command stream, and shader ISA by studying how these blobs work. He studied these by examining and manipulating command stream dumps. Based upon this documentation, the Gallium 3D driver Etnaviv is being written. Vladimir's work was inspired by LIBV. Due to the simplicity of the Vivante hardware, Etnaviv has surpassed what LIBV has achieved quicker than similar projects. The project has produced a functional but unoptimized Gallium 3D LLVM driver. The Etnaviv driver has performed better than Vivante's own proprietary code in some benchmarks. It supports Vivante's product line of GC400 series, GC800 series and the GC1000 series. Etnaviv https, github comptnaviv, bltsville http, graphics github io is an open 2D API, usable for the 2D graphics chip Vivante GC320, included in Texas Instruments OMAP4 or as software only. Qualcomm Qualcomm develops the Adreno GPU series, and include it exclusively as part of their Snapdragon. In 2012, Phoronix and Slashdot reported that Rob Clark was working on reverse engineering drivers for the Adreno GPU series. Clark wrote in a referenced blog post that he is doing the project in his spare time, and that the Qualcomm platform was his only viable target for working on open 3D graphics since his employers were affiliated with the Imagination PowerVia and ARM Mali cores, which would otherwise have been his primary targets, and that he already had working command streams for 2D support, and that 3D commands seemed to have the same characteristics. The driver code was published on Gitorius under the name Freedreno. It has since been moved to Mesa. In 2012, a working shader assembler was completed and demonstration versions were developed for texture mapping and Phong shading using the reverse-engineered shader compiler. At FOSDEM, February 2, 2013, Clark demonstrated Freedreno running desktop compositing, the XBMC media player and Quake 3 Arena. As of August 2013, the kernel component of Freedreno, called MSM driver, was accepted into mainline, and is available in Linux kernel 3.12 and later. In July 2014, the DDX driver gained support for server-managed file descriptors, requiring Xorg server version 1.16 and above. Freedreno, http Freedreno github.io/https, archive FOSDEM.org edular Freedreno /https, github comp Freedreno video acceleration. Broadcom Broadcom develops and designs the video core GPU series as part of their SoCs. Due to the fact that it is used by the Raspberry Pi, there has been strong interest in a FOSS driver for video core, and on October 24, 2012 the Raspberry Pi Foundation, in cooperation with Broadcom, announced they open-sourced all the ARM code that drives the GPU. Unfortunately, the code released at that date reflected the very minimum needed to make an open-source announcement. The open-source components allowed message passing between the ARM's CPU and video core, but offered little insight into video core and little further programmability. This was because the video core GPU runs an RTOS that handles the real processing. All of the actual video acceleration is done using this RTOS firmware coded for its proprietary GPU, and this firmware wasn't open-sourced at that date. Further, as there was neither a toolchain available that could target this proprietary GPU, nor was its instruction set documented, so no possible advantage could be taken in case if the firmware source code was made available. The project video crew tried to document the video core GPUs. Based upon this documentation, a driver could have been written. But on February 28, 2014, on the day of the second anniversary of the Raspberry Pi, Broadcom, together with the Raspberry Pi Foundation, announced the release of full documentation for the video core for graphics core, and a complete source release of the graphics stack under a 3-clause BSD license. The free licensed 3D graphics code was committed to Mesa on August 9, 2014, and first appeared on 10.3 release. Official Broadcom documentation, http://www.broadcom.com support video core IVAG100R PDF. Other vendors SIS and VIA have both shown limited interest and communication regarding open-source drivers. However, both have released source code which has later been integrated into Xorg by FOSS developers. In July 2008, VIA opened up documentation for their products to improve its image within the Linux and open-source communities. Although, so far VIA has failed to work with the open-source community to provide documentation and a working DRM driver, leaving expectations for supporting the Linux operating system unfulfilled. On January 6, 2011, it was announced that VIA was no longer interested in supporting free graphics initiatives. Displaylink have announced an open-source project called LibDLO with the goal of bringing support for their USB graphics technology to Linux and other platforms. The code is available under the LGPL license. It has not yet been integrated into an Xorg driver. Displaylink graphics support is available through the kernel UDLFB driver in mainline, and UDL DRM driver, which as of March 2012 is only available in the DRM next tree. Often other non-hardware related vendors may also lend a hand to free graphics initiatives. Red Hat has some employees working full-time on several free and open-source software projects, such as 2 full-time employees working on the free software Radeon and 1 full-time employee working on the free software Nouveau graphic drivers. In addition, the Fedora project runs a Fedora Graphics Test Week event before the launch of their new Linux distribution versions in order to provide rigorous testing to free graphics drivers. Other companies that have provided development or support include Novell and BMW ARE. Open hardware projects. Project VGA aims to create a low-budget, open-source, VGA-compatible video card. All information to create one is available, but at present there seems to be no development. Some data, PCI bus interface, Xilinx Spartan 3S 400 FPGA, 16 MB SDRAM, board programmer with USB interface, VGA connector. The Open Graphics project is another aim at creating an open hardware GPU. The Open Graphics device V1 features dual DVI outputs and 100-pin IDC connector. On September 2010, the first 25 OGD1 boards were made available for grant application and purchase. The Milkimist system on chip, targeted at embedded graphics instead of desktop computers, supports a VGA output, a limited vertex shader and a 2D texturing unit. Although these projects may exist, if they use FPGAs, they tend to have partially or completely non-free and closed-source toolchains. There are relatively few FPGAs with completely open-source toolchains. See also: Intel GMA, Direct Rendering Infrastructure, High-Priority Free Software Projects, 3D Computer Graphics, Open Graphics Project. References. External links: Linux graphics drivers from Intel, NVIDIA's Unix drivers portal page, Project VGA, Direct 3D 9 state tracker on Gallium 3D, D3D1X, add new Direct 3D 10/11 COM state tracker for Gallium.